Hello, and welcome to Physics 36. All right. Well, by looking at the list of people in the class, I know that many of you had Physics 35 with me, although quite a few of you didn't. So we're going to run through some basics of the class, what to expect, when we're going to see each other, and all that good stuff. Okay, so I'm going to be doing a couple things here. I'm going to be talking about the syllabus, which is the document down here in the lower left-hand corner, and I'm also going to be showing the Canvas page where our focal point of the class is located. All right. So here we are in the welcome video recorded on the Monday, January 25th, first day of the semester. All right, so one thing to look out for, first thing to consider is we are going to have class meetings. This is different than the way I did Physics 35. I'm going to have actual class meetings. So every week on Tuesdays from 1:50 p.m. to 2:35 p.m., we're going to have a class meeting. So that 45-minute period of time is our set aside time for class meetings. Okay? That also means I won't be recording a weekly look ahead video because on Tuesday we'll always have a chance to check in, and I'll cover the basics in the first 5 minutes of that class meeting, and that's what you can expect. Okay, that's going to be an opportunity to go over material for me to decide to pay special attention to material in a little bit more depth than I would in the weekly look ahead video because of the kind of that interaction. But things that I know are coming up from the lectures, that are coming up from the homework, I will definitely talk about that. It will also be on a small scale and an opportunity to introduce that week's challenge problem. Certainly, I'll talk more about that later when we'll be talking about those. Um, it also is going to be an opportunity for you to talk about your presentations, your participation. Okay, and I guess you would present them. All right. So the idea is I'll say, I noticed so and so posted a solution in our participation thread for this week. Please, take a moment and talk about your solution. You can just say a couple words. You don't have to say much at all. But I'll definitely be kind of going through and seeing if I can get people to talk a little bit about their solutions. Okay. So I think that will always be something we can do. If I'm not filling the time with ideas that I want to get across to you, we're going to have that back and forth. And obviously, it's a great opportunity to come with questions because I'll be there. Okay. All right. Additionally, I'm going to be available for office hours. So if you take a look on Mondays and Fridays, I'm available for office hours. Okay. Those are times that I'm going to be there in office hours every Monday and Friday for 1 hour. Okay. I'm also going to be doing office hours on Zoom. Obviously, works better. Okay. And so it's going to be the following Zoom link is where I can be found. Okay. As far as best way to communicate with me, although my email is listed here in the class syllabus, by far the best way to communicate with me is in Canvas. I'm going to be looking at this inbox for messages, and that's going to be the number one place that I'll be on the lookout for communications from you all. Okay? Other than expecting you to show up to office hours and class meetings. All right? Now, the other scheduled thing is going to be the exams. So I'm going to schedule all the exams in the lab slot. Okay, so all scheduled exams are going to take place where the class is listed. We're not going to have unlisted times anymore because I know that was sometimes a conflict and obviously a big hurdle. Okay, so although the day of the week, Tuesday, requires a little bit of finesse, that is when I'm going to have all of the exams. They're all going to take place on Tuesdays when we normally be having labs, which is how it would happen in an in-person class, and they're going to be from 2:40 to 6:40. So I gave a little bit of extra time so we could have a full slot there in terms of a full 4 hour slot for the exams. But that's the scheduled time plus a little bit. Okay. All right. So you can see that then as far as on a week that we'd have a class meeting, we'd finish up the class meeting and the exam would start immediately after that, just with a 5 minute pause or effectively immediately. Okay. All right. So you can ask me questions, but hopefully this all makes sense. Make sure to look at the document, watch this video, and so on. We're using College Physics 11th edition. That's the author is Surway, the primary author. Got the intended class outcomes, format and structure. So the main part of the class is the Canvas page. It's broken up into modules. For example, this is the first module up. It's the Welcome and Chapter 15 module. All right. Now we're going to have one module per chapter, and we essentially have one chapter per week, which means we have one module per week. Every module is going to have the same structure to it. It's going to have lectures. It's going to have homework. It's going to have a reading quiz, which is always posted before the lecture because the reading quiz is meant to be done before the lectures, although often the lectures will be done ahead of time. All right. And then the challenge problem, then a lab, and then an opportunity for participation. Okay. This is going to be the format of every module for every single chapter. Okay. Now, One thing that's a little bit different from Physics 35, you have me for Physics 35, is I've cut down on the clutter per module. So for example, there's only going to be one page per lecture rather than separate documents that you see. So definitely I've condensed things more into pages or to assignments. So there's going to be fewer separate, kind of rows on a given module. There's just more per. So for example, if we click on this lecture here, this will be a good example of that. You'll see that there is the blank lecture. Okay, that's what you can use to go through the lecture yourself. Okay, then underneath there's the video. Okay, which is on YouTube. I have a YouTube channel with lots of classes, lots of videos. There's going to be opportunities for you to watch videos from other classes where they want to review, or from classes where just similar things are being taught. Okay. Certainly, last time I taught Physics 36, there was this same opportunity to have some online classes. Okay. So you can find that all there on YouTube, and there's a particular playlist for this class. So all the videos that are relevant to this class. And then there's the document, which is the post lecture notes. It's with all the handwriting that you see me filling in the lecture video. Well, that's going to be a separate document. Okay, so that means that every page this lecture has those two documents, the before and after, and it's got the video. Okay, all right. So that's what a given lecture looks like if you click on it from any module. Okay, and then obviously you can continue on within the module and go to the next thing, and there's another lecture and so on. Okay, so far lectures 1 and lecture 2 are complete like this. I need to put some finishing touches on lecture 3 for this week, which is actually called lecture 2.5. I'll address that right now. That's because this is one of the few lectures that isn't a crossover between every version of this class that I would teach with different textbooks at different colleges. And so since it is somewhat of an optional section that is important to the way the information is presented in your textbook at this college, I need to include it here. And so, but then in terms of my own numbering system, that it is kind of a tentative thing, then it's called 2.5. We might see that at most one more time this semester. I know it's weird to see it, but for the most part, it's just gonna be 1, 2, 3, so on. And they're all gonna have names like this. I think these names are more intuitive than previous naming conventions where I included these sections. However, I will add a parenthetical note to the modules that will say what sections they come from. All right, so that you will be able to cross-reference these titles, like lecture 1, electric charge and force, to the particular sections in your textbook that cover electric charge and force. All right, so but the title of the document itself is more general. Okay, so enough about the nuts and bolts of that. Let's get on to other aspects of the class. We've got homework. All homework and reading quizzes are through, well, WebAssign. Okay, so for example, if you click on the homework, then you'll see that you can follow this link and it will take you to WebAssign. You have to have a paid account with WebAssign to access the homework and the reading quizzes. Okay, so homework and reading quizzes are behind a paywall. They're through they're not Pearson, but they're through the publisher, and McGraw-Hill, and it's actually pretty good. I mean, it's a pretty good service. There's a lot of the interactive aspects of the homework I think is really worth it. I think it's a good complement to the other things we do in class. So that's why I go ahead and include this paid for homework and reading quizzes. Okay, and there'll be one of those each week. There's particular due dates that you can expect to find the homework and the reading quizzes due on. All right, so moving right on, we have labs. All right, so there's labs every week. Most of them are simulations, especially because we're getting into more modern physics. Some of them, however, can use fairly everyday objects. So I have a list of inexpensive objects that are going to satisfy 3, potentially 4 labs. Okay. Now that said, it is a total of a $40 investment. So if you want to split it up among other people in the class, for the at-home labs, you can work in groups of 3. For any of the simulations, like you can see over here, lab 1, that's a simulation. In any of the simulation labs, you can only work in pairs or individually. You can always work individually, you can always work in pairs, but there's an exception that you can work in groups of 3 for the at-home labs, okay? It will be clear which ones are the at-home labs. I'll remind you if you have any questions, but I think it's really clear which ones are simulation-based and which ones are not, okay? Okay, the equipment, by the way, is an inexpensive multimeter. I think I have one here somewhere. Let's see, where's my multimeter? I have the lasers nearby. I was just thinking I might show you the multimeter. But it's a very everyday device that you can readily purchase. Those are actually quite affordable. Okay, so I would definitely recommend getting one of those. Then you also want to get a set of magnets. You want to get neodymium magnets. These are the strong ones. They're sometimes called rare earth magnets. That's the kind of magnet you want to get. A set of 10 would be sufficient, but you need enough so that we can gradually increase the magnetic strength by stacking magnets. And it's just going to be, basically looking at the relative strengths of magnets in a sort of a at-home forced setup type of lab. Okay, I think it'll be interesting. I think it'll be a good opportunity to work with those magnets. Okay, the last lab is a really neat one. It's going to involve the diffraction of light, and it's going to involve using lasers like this one here. I bought a set of 3. They sell them on Amazon. I can share the link in the class meeting if someone wants to ask about it. But they sell them in these sets of 3. They sell them as a cat toy. There's a purple, a red, and a green laser. My set worked really well. Some reviews say they don't all work well. Mine work really well. So you can see that I have the laser here. All right, so you can see quite bright laser. Okay, so the idea there is that we're going to use this laser and one of your own hairs to measure the diffraction pattern that's made by the laser as it passes around your hair, and then calculate the width of your hair. It actually works really well. It's a great lab to do at home. Okay. All right, but if you only have a single laser and you don't have the set of 3, you can do most of the lab, and we'll talk about that when it comes up. Okay, so that's some lab equipment that you'll need for 3, possibly 4 labs, because the multimeter I might use in more than one, but certainly that's the way things look so far. Okay. All right, so hopefully it all makes sense. Again, most of the labs are simulations, and certainly once we get into modern physics, like nuclear physics and so on, they're all just going to be simulations. There's participation credit. To reference the module again over here, you see chapter 15 participation. So participation is required. You need to get credit for participation. It's done by solving the unsolved problems in the lecture notes, solving them and posting your solution to the relevant chapter's, discussion board. Okay? All participations are due on the day of the exam that covers the chapters that you had an opportunity to participate for. You don't have to participate every week, not at all. You only have to participate a total of 6 times throughout the semester. Okay? So that means that you'd be doing it over six separate weeks. All right? Now, one thing that's different from when I taught Physics 35 is that I'm not doing a study guide anymore, which is good, and I'll tell you why. It's good for you, okay? Because the study guide was fairly redundant, because I was adding all those extra unsolved problems to the ends of the lecture notes. So what I've done this semester is I've added a few more problems to make the unsolved problems at the end of a set of lecture notes more robust than they would have been before. So let's go to lecture 1. I'll scroll down and show you. So I have a nice long list of unsolved problems for every set of lecture notes. Okay, see, case in point. As you can see, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So plenty of problems to go around. Okay, so there's going to be somewhere around 20 of those per week. Okay, that's plenty of problems to draw from. That represents the study guide. So then when we get to the exam that covers those chapters, of which those lecture notes were relevant, well, when I say that 40% of the exam, or 4 out of the 6 computation problems, come from the study guide, they're going to be coming from those set of problems. And I will recompile them into a separate document that I'll post like the week before the exam that says study guide. But it's all the same problems that you'd find in the lecture notes anyway. Okay? So that means that's where you'll be doing all your participation, and then you'll know that those are also your study guide. So it actually makes it even more valuable to do the participation and pay attention to your classmates' participation, because all the solutions get collectively solved by the class, means that you can reference those in the open note exam on the day of the exam, right? Okay, so there's a real positive feedback loop in terms of paying attention to those problems, practicing them, and I've really carefully chosen them to represent the same material that I'm presenting in the examples in the lecture notes. All right. Now there's also a challenge problem, right? I love my challenge problems. It's a way of I think having something interesting every week. Okay, memorable experiences. I know they can be frustrating at times, but they show my idiosyncratic way of teaching. I write these myself, right? So we're always going to have one challenge problem per week. Okay, this is the same as I did in the Physics 35. Those challenge problems will always be on the Monday following the week's material that's presented, for that challenge problem. Now, if there's a holiday on a Monday, I think we have one, then obviously I'd have to adjust, but otherwise they're always on Mondays. Now, I mentioned I'd come back to the schedule and challenge problems and so on, because that means our class meeting is on Tuesday, right? The challenge problem will already be up, but it's not due till the next Monday, so you're probably not thinking about it yet. So really, the best opportunity to talk about the challenge problem is during either the Friday or Monday office hours, which hopefully makes those schedules really seem to make sense. Because I think at that point, by Friday and certainly by Monday, the day that the challenge problem is due, then you really will be thinking about it. Now, challenge problems are interesting in that there is a problem, okay, that has multiple parts as posted every week. And then there's an assessment that asks you to solve one part of that problem, asks you a new follow-up question, and then a two-point extra credit question, often conceptual. Well, the assessment will be posted within the same assignment, labeled challenge problem, whatever number, on the day that it's due. And I have a little note of that for challenge problem 1. Okay? Now, of course, we have exams. The days of the exams are on the calendar. And as I mentioned before, exams will always take place Tuesday evenings, time you should already have blocked out because that's scheduled class time. Okay? All right. The format of the exams is a mixture of conceptual and computation problems. The conceptual problems can come from the reading quizzes, past exams, and so on. There are 8 of those. And then there are going to be 6 computation problems, 4 of which come from the study guide, 1 of which comes from the set of challenge problems that were covered before that exam, and 1 wild card, often coming from the lecture notes, but not necessarily. Okay? All right, so we can certainly talk more about exams when we get closer to their dates. We have a breakdown of all the points. You can see that reflected in the gradebook. I'll be updating and making any tweaks to the gradebook in the first few weeks. But then we can see the calendar itself, which is one reason you might actually want to refer back to the syllabus document. You need to check some dates. And this is great because it tells you the due dates in any given week. You can see that for week 1, we have a reading quiz due on a Thursday because it's unusual on week 1, okay? But if you look on week 2, we have a reading quiz due on a Tuesday. That's typical. Reading quizzes are basically always due on Tuesdays. Why Tuesdays? Because I consider that the real turning point. I'll already be posting things like the homework and so on, starting to get up maybe blank versions of the lectures, and actually in the case of your class, I'll be getting them up with videos, okay? And then, you can start taking a look at that, and by Tuesday, you can take the reading quiz. Now, you shouldn't have to watch the lecture videos to take the reading quiz. The reading quiz is a standalone easy quiz with just a few definitions that you should be able to do without watching the lectures, without much studying. It should just be the initial pass of the material from the chapter. Okay. Then we always have a lab due on a Wednesday. You can see that, and that's the previous week's lab. That's the last thing that you turn in from the previous week. No big rush on the labs. We just got to get them in. Okay. Then we already mentioned that challenge problems are always due on Monday. That would be the previous week. All right. And then you always have a homework due on a Sunday unless it's a holiday weekend. Okay, so that's the format for a given week. You can see 1 chapter per week. All right, and then when we get up to an exam held on a Tuesday. So the nice thing about having the exam on a Tuesday is it means that we get a transition to the new material faster. So there's less of a kind of a buildup of having an exam as we're doing a Physics 35, for those of you that are with me in Physics 35, having the exam on the next Friday, which gave you more time to study for it, but also meant that it bled into the new material quite a bit, which meant sometimes that you felt like you were rushing to catch up with the new material, having finally take the exam. So we're gonna get the exam out of the way faster, but that also means you wanna make sure that you're really studying for it a lot over the weekend, the Monday and the morning of the day of the exam, because there's a little bit less time to prepare for it, but I think some focused studying can more than account for that. And I'm actually really looking forward to this new schedule. Okay, and so you can see there's exam 1 happening on the 23rd of February, 16th of March we got another one. All right, and then finally we've got one on the 20th of April, all on Tuesdays. Okay, so there's no variability there. You always know exactly what day to expect. The final exam is just our last class period. There's no final week at Los Bananas College, and so it's just going to be on Thursday. And I blocked out some time, basically around the time that we'd have class, but just extended it out significantly. So it's from 10 to 4, so you got lots of time, okay? All right, and if you have any conflicts, let me know regarding those exams, but that's the layout of the due date. In terms of the material, we spend the first 4 chapters discussing electricity, then we have an exam on it. Then we cover 3 chapters on electricity and magnetism, how do the two interact and so on. And that smaller set of 3 chapters has its own exam, although it's a more complex set of 3 chapters in the first 4. Then we have a set of 4 chapters that cover optics, an exam on optics, And then finally, we move into modern physics, relativity, atomic, and nuclear physics. All right, and then that concludes everything. We have our comprehensive or cumulative final, which is going to be about 1/3 new material, modern physics, and then the 2/3 of the material that was covered on the first 3 midterms. Okay, I got some important dates to keep in mind, and that basically wraps everything up. So I look forward to seeing you all on our Tuesday meeting and staying in touch with all of you via office hours and messages on Canvas. Welcome to Physics 36. I think it's going to be a great semester. Bye for now.